Okay, and we're back. We ended on this page, halide atomic structure. Let's keep going. Here we go. Okay, so some other stuff about minerals. I know you don't have this in your package, just follow along. So this is a Ford Explorer, okay? And this is a Ford Explorer, and this is a Ford Explorer. Okay, so they're all the same exact car. Now, the point I'm saying, the point of bringing this up is the fact it's about color. Okay, so color is a weird thing with minerals because the general rule is you can't rely on color to tell what a mineral is. But with some you can, so there's weird exceptions. There's so often exceptions in life, and in the natural world, there's often these weird exceptions. But most of the time, we say you can't really rely on color. So for instance, you can't say, this is a Ford Explorer, how can you tell? Because it's red. Well, but there are other Ford Explorers that aren't red, so you can't use the color to determine it's a Ford Explorer. You have these other characteristics of the shape of the headlights or the shape of the body or whatever that may be. And minerals are the same way. That's my point of why I bring this up. So what I say is color is useful to identify minerals, and it more like sort of can narrow it down. But for some minerals, it doesn't really help because I'm gonna get here with like minerals that are sort of whitish or maybe like a light gray. There are hundreds of those, so you can't just pick up a mineral and say it's white. I know that it's calcite because there are a lot of other minerals like that. And graphite, galena, those minerals are black, and there are a lot of minerals that are black, so you can't just look at it and say it's black, though it can help you narrow it down. So for instance, we'll get back to that in a second, we'll fill that in. So quartz, a really common mineral, and when quartz can really, in some situations, they have some other inclusions in with the quartz, some other elements in it that give it different colors. So for instance, typical quartz that we often will see are one of these two. Quartz crystals are often clear. They can look like diamonds. Sometimes they can look like diamonds. Now they're not diamonds, but they have a sort of a diamond look at times. Or milky quartz, which, milk being white. A lot of the quartz we see is this. There is this, I'm not sure how well you can see it here. Smoky quartz is like a brownish color, hence, the name smoke. Amethyst, and this we see this around. I see these like mineral shops that people collect minerals often have it. Very purple, which is really cool. Citrine, and I guess it's the idea of citrus is the name, and oranges, it has like an orangey color, and rose quartz has a pink color because many roses are pink. Although there's a lot of roses are different colors too, but that's what they call rose quartz, is the pink one. So I really like this sample. This is citrine, a type of quartz based on color. Great sample. This is how the mineral crystals will grow. If it's somehow underground in like a little cave or something, it has some space to form. It can form these mineral shapes. Look, that's a hand there. So this is pretty cool. I mean, it's pretty big actually. So the idea here is you can't tell quartz just on color because there's a lot of different colors, right? So that's really what I'm getting at here. So please pause this and copy this down now. Right, let's go back here. Right, so quartz, calcite, halite, talc are all white. Graphite and galena are both gray, or they're grayish, blackish, but they're dark colors. So that just gives you a sense you can't really rely on colors, but sometimes you can. There are some minerals that are like sulfur is yellow pretty much all the time, or olivine. We also say olivine is olive green. It's like a greenish color. So it's this, identifying minerals really ends up being a bit of a skill, and we will use the back of the reference table will really help with that too. So here we go. What's up next? So another property of a mineral is how it will break, okay? Like if you took a hammer and you broke it, what would the shape look like? So there's two ways that the breakage of a mineral we call it cleavage or fracture. Okay, so we'll start with cleavage. Cleavage means think about if you have like a meat cleaver, like it cleaves really nicely, like along a flat side. So if a mineral has cleavage, if the mineral breaks with any sort of pattern or breaks with any flat sides. Take some time to copy this down, and then I'll talk about it. Okay, I'm back. Breaks any sort of flat sides to it, or breaks with any defined angles, that is all cleavage. And then what I wrote here, sometimes these flat surfaces are hard to see. So you have to sort of hold the mineral and you have to hold it up to the light and go like this, and you'll see little flashes back at you, and those would be the flat surfaces flashing back. That's a little tricky, and you really need a lot of experience doing that. So if you see flashes, they're from very small flat surfaces. And sometimes in class when you're starting, we don't even show that because that's a little difficult. We show things maybe more like this, platy cleavage. This is just a diagram, but some minerals will break really flat, almost like sheets of paper will come off, which is really cool. The micas are a great example of that, and mica is one of my favorite minerals. Kids really like mica too. Hopefully we can get you to see some of that in real life. And then halite, again, this is back to table salt again, has this cubic cleavage. This was a large chunk someone broke with a hammer, and it breaks with flat sides. It looks as if someone cut it. It's pretty crazy. It's pretty crazy. It looks like someone cut it, but it breaks that way naturally, which I've been doing this a long time, and I'm still like kind of fascinated by it. I still kind of love that part of it. So that's cool. So let's show some examples of this. So we're gonna go here. Now, this is a little bit detailed here, and but just bear with me. So there's different types of cleavage. So these mineral pictures don't come out great. The problem with the minerals is it just doesn't come out great on the screen. It's just hard to take pictures of. But just this diagram kind of shows it, and then these shows the different directions of cleavage. So this is one of those that breaks in sheets of paper one way. This will break sort of in this direction and in the yellow direction. So these sort of right angles to each other. This can break having 3 directions of flat sides, kind of like that, and it shows the different sort of directions of cleavage, the white and the yellow and the green. And notice they're sort of like tilted. So the angles here are not, they're not 90-degree angles. They're not straight up and down. They're sort of tilted. And then this one here has 3 directions, but they are at right angles. So just pause the video now, copy this stuff down into your notes. Okay, so we'll say 3 directions at 90 degrees. And this is pretty deep stuff. If you're maybe not getting this, that's okay. You really need to see this in real life if you can. And if you can't, that's okay too. This is, we're really working on the other basics, but it's cool when you can see it. So what would be the name of this shape? It's not a square, right? Because a square is gonna have a 90-degree angle here, a 90-degree angle here, be kind of straight up and down. Does anyone know the name of this? We're gonna see if you're right. It's called a rhombus. That's what this shape, geometry is called. It's called a rhombus. You may not know that, and most people don't know it. That's okay. But what that leads to is when you have a mineral like calcite, we say it has rhombohedral cleavage, and that can be a little tricky to see in some of these pictures. Maybe I have the next one. Yeah, this kind of shows it here. So this is calcite. I kind of outlined it here. So notice this is it's not these 90-degree angles here. So we say it has a rhombohedral cleavage, but what you're seeing here, look how flat that side is, how flat that side is. This has been broken. You can break it with a hammer and it breaks in that shape really cleanly, which again, fascinating to me. I hope it's fascinating to you. As opposed to, and I love, this is one of my favorite pictures. This is halite. Again, we keep coming back to halite. This shows cubic cleavage. So this is where all of the angles are very 90 degrees here. So that shows the difference between the rhombohedral cleavage here and cubic cleavage here. So and this is fluorite. We'll get to that a bit later, I believe. So, and this is biotite. Again, the mica is biotite, muscovite mica. What you can see here, it does look like pages of a book. I hope that you can see the pages of a book. And this piece peels off. You can peel them off, and they can be like paper thin. You can see through them. Sometimes you'll get pieces of them that break off, and kids will look at it and say, this thing got mixed in with the mineral. I go, no, that is the mineral. And it's like flexible. It sort of has a bit of almost like it's like a plastic feel to it. And these really thin sheets. And it rocks you when you see a rock that has a lot of, this is called biotite mica. There's also muscovite, which I think I just said. They look, little pieces of it look really like silvery, and they really like shine back, and they have like a really cool shiny speckled look to them. So we'll see that in some rocks, hopefully. Okay, so please, this is just some examples here. We're gonna write this down at the bottom. Please copy that, but not this. pause it and copy that stuff right now. Okay, we're back. Okay, so we've spoken about cleavage, went into a lot of detail on cleavage there. The other way it can break, if it doesn't break with any flat sides or any pattern or any like really noticeable angles, it just breaks in no pattern. We call it fracture. Okay, so please pause it and copy this now. Make sure you've underlined the note. So fracture is also mineral breakage and is when there's no pattern or flat sides to a mineral when it breaks. So the broken surface is jagged or uneven. An example I often use could be like broken glass. It doesn't really break into any particularly straight flat sides. So what do I have here? Oh yeah, so I have some examples of fracture. So this is just try to get some good photos of minerals that show fracture. This here is not like just sort of, this is not a perfectly flat side. I hope you can see that in the picture. This too, this is olivine fracture, sort of random. You don't see exact flat sides, really defined, noticeable angles. Some of these minerals that have cleavage will have like steps. It looks kind of like steps in there. Fracture does not have that. And then there's another one here. This is also fracture. This is really glass-like in its breakage. So, okay, so we have this down from here, I believe, right? Oh no, we don't. So now we're going to copy this bottom part now. Please pause it and copy this down here. And this is definitely getting more detailed, okay? There's a lot of high schools that don't do this as thoroughly as we're going to do it. They're going to really, it really helps, I've learned, to understand all of this. It really builds your knowledge on minerals and it will help you appreciate it more. So the crystal shape is the natural shape that the mineral will form if it has some room to grow, like in like a small cave, let's say, for instance. So for instance, like quartz will form this crystal, but if you broke it, it's going to have fracture and just break randomly. So it forms this shape, but it breaks unevenly fracture. Halite has that shape too. And calcite will have this shape. My example of this, I worked for years to come up with an example. The best one I can come up with, it's not great, is an orange that you will eat, right? So the shape of an orange as it grows is this. Now think about if this orange fell off the tree and sat on the ground, and then the outside, the rind, the peel of the orange sort of like broke away because it's decaying. How would the inside of the orange start to break? Right, start to break in some kind of like pattern, right? Because the inside of the orange are going to have these little orange shapes. So that's me. It will break in these shapes, though the real like sort of crystal shape of it would be this. May not be the most satisfying example, but hopefully you can see what I'm talking about. This is the crystal shape of quartz. If quartz has some space to grow in the natural form that it will grow this. This is pretty big. This is pretty amazing. People collect these. They're awesome. I hope you get to have one someday and be able to appreciate just the awesomeness of nature. It's pretty great. But if you hit it with a hammer and broke it, it would just look like almost like surface of broken glass. It'll have fracture. It does not look as nice as this. The bottom part here where it's broken does look that way. You may not be able to see it. I don't know if I'll be able to do this. Hold on, let me see. Can I get to this 1 second? Let me see if I can. Hold on, I had it up and then let me see if I do that. Okay, yeah, so this is kind of cool. So this also gives some crystal shape too. So I'll look, because I get to move here, I'm gonna do this. Right, click on this and I can this is called cubic cleavage. So this is, would be cleavage in 3 directions, 90-degree angles. That's kind of cool. That's kind of makes sense. This is called octahedral cleavage, and this is something that like fluorite would have, right? So that would be the shape. This octahedral cleavage shape, crystal shape. I'm sorry. This is how the crystals will form naturally, and there are a lot of them. Here's just some here. So this is called. Look at that name right there. This is a mathematical term. Dodecahedral. Look at that. So it can get pretty complicated. When you really get into minerals, it can get pretty crazy, some of these aspects to it. And some of these here, I mean, like this one here, highly modified cube, that's pretty crazy. Not common in the mineral world, but it does exist. Pretty crazy that nature can form those shapes. So I just wanted to show that before we continue on. Yeah. So, right, I'm going to do that, and then I'm going to do this. Yep, and then I go to here. Okay. Hardness. This is one kids often get wrong. It is resistance to scratching. It is not breaking. Resistance to scratching. Resistance being scratched. It is not the resistance to breaking. We often use our fingernail to test, or we use a glass plate, really. Use a glass plate. So, super hand. Do the hardness test with your eyes closed. You'll be able to feel if it scratches or not. If it scratches, you can feel it dig in a bit. If it doesn't scratch, you can glide across. So I often tell kids to have their eyes closed when they have a glass plate. I'm going to show you an example of a glass plate in just a second. Please pause this right now and copy this down. Okay, so what they did, the Mohs hardness scale, this gentleman named Moh way in the past came up with a pretty simple scale. They just put some basic minerals in order of like lowest hardness, I don't say softest, least hardness to the most hardness. And they put in a scale of 1 to 10. So let's start with 10. 10 is diamond. Okay, if it's resistance to scratching, diamond has the highest resistance to scratching of anything. So basically it goes like this. Diamond, if I had a diamond could scratch everything else here. Can scratch it. But none of these can scratch a diamond. Nothing can scratch a diamond except another diamond because it has the same hardness. So a diamond can scratch a diamond. And like the lowest hardness here would be like talc and gypsum, like baby powders, often really called talcum powder. And that is the mineral talc ground up really fine. And then it's such a low hardness. I mean, you put it on like babies and stuff. It actually feels kind of soft, though it's a mineral, which is really cool. The one thing we often test, glass is hardness of about 5.5. Your fingernail is about 2.5. So we often take the minerals and rub them on glass, sometimes our fingernail.